the beloved Piper Cherokee. Introduced in 1960 as a safe and affordable aircraft, over 50 years later, pilots continue to adore its qualities. What is it about the Cherokee that has allowed it to endure for so long, even years after computer-designed carbon fiber aircraft flow into the market? Let's take a close look at the Piper Cherokee and how it compares to similar airplanes. The most popular rival to the Cherokee would have to be the Cessna 172 Skyhawk, which here at A2A we have extensively flight tested during our development of the Accu-sim C-172 trainer. The immediate contrast between these competitors is the position of the wing. Without getting deep into a Cessna high wing versus Piper low wing debate, let's review some factual information about the real-world differences between the two. Generally speaking, a high-wing aircraft has an advantage in backcountry bush flying, aerial photography and ground observation. And also a high wing makes for a nice shelter from the sun and the rain when parked on the ground.
Great advantage to a high wing is you have instant shelter wherever you go.
These are all pretty decisive advantages in these real-world applications. More generally speaking, the low wing has an advantage of upward visibility, especially when maneuvering in the landing pattern. Aside from these differences, it really comes down to personal preferences. Looking beyond the visuals, there are differences in the way these two rivals fly, especially when things get slow in the air. The Cessna 172 will easily drop a wing if the pilot continues to fly it in a stalled condition, which is a desirable trait for a training aircraft. The Piper Cherokee, on the other hand, is almost unique in that it can continue to fly even when in the stall. Almost regardless of power and attitude, the stubborn little Cherokee maintains aileron effectiveness even as it continues to mush and sink at a rapid rate. This is a critical safety characteristic designed into this aircraft by three brilliant minds working together.
The team that designed the Cherokee, Burgee, Wyke, and Thorpe, were three of the keenest aeronautical minds in the general aviation field at the time. Any one of them could have designed a wonderful airplane, but to put the three of them together, that was really what helped make the Cherokee such a brilliant design.
The original Cherokees were built with a constant chord wing. To illustrate, let's look at two popular examples of a traditional wing. Notice how both the Skyhawk and the Bonanza wing starts with a wide wing root and tapers as it moves out towards the tip. Now look how the Cherokee wing maintains a constant chord from root to tip.
That constant chord wing in the Cherokee really set it apart from the other airplanes that were out there at the time, and even since then, because without having a tapered wingtip, you don't have a tendency to have the wingtip stall before the root. But something about the way the Hershey bar wing works, we say it was Hershey bar because it looks like a rectangular, candy bar.
The Piper Cherokee also uses a newer cantilever-style wing, which is internally supported and therefore requires no external struts or bracing.
Prior to the 1950s, general aviation airplanes were non-cantilever. That is, they needed struts to hold the wings up. You see that in virtually all planes. And Beechcraft Bonanza came out in 47 with a low cantilever wing, and that really was the beginning of modern general aviation. They broke the mold. There was nothing prior that looked like that. It was built like that.
The Beechcraft Bonanza was built with 1940s technology, while its rival, the Piper Comanche, came out a decade later, showing off many advancements, one of which was an all-new modern laminar flow wing, a battle-tested design borrowed from the North American P-51 Mustang. Let's look at the cross-section of the wing on a Beechcraft Bonanza. Notice how the thickest part of the wing occurs about 25% back from the leading edge. Now let's look at the wing on a Piper Cherokee, which borrowed its laminar flow shape from the Comanche. Notice how the thickest part of the wing is pushed back to about 40% from the leading edge. This is called laminar flow because the air can more easily follow this contour. However, probably the biggest benefit the laminar flow wing brings to the Cherokee was the ability to place the main wing spar further back so it could actually pass through and below the rear seat, effectively creating one solid continuous spar.
The Cherokee feels very substantial, very well put together, and solid. Feels like it's just going to hold together under any kind of stress you're going to put under it. It gives you a sense of calm, I think, when you're flying one, especially in turbulence and adverse conditions. If you feel like you could put that airplane down on a rough field, it would not rattle around very much. And in fact, that's true. They are very substantial airplanes.
And another general difference you'll notice between most high and low wing aircraft is the amount the wingtips angle upwards, known as dihedral.
Well, the low-wing airplanes require more dihedral than high-wing airplanes because the vertical center of gravity is above the wing on a low-wing airplane, but below the wing on a high-wing airplane. So when you have most of the weight sitting on top of the wing, it wants to fall off in any direction. You have to correct that by increasing the amount of dihedral. So you have 7 degrees dihedral in a Cherokee, but only 3.5 degrees of dihedral in a Cessna 172. But the dihedral of the Cherokee is another just perfect touch. Too much dihedral and you get too much sensitivity and turbulence, and it reduces roll rate. And anyone who's ever flown a Hershey bar Cherokee knows you don't have any problem with roll rate. That is a fast-rolling airplane, almost to the extent of a aerobatic airplane. So the dihedral of a Cherokee, I would say, they just hit the note just perfectly.
And finally, the main difference you'll see is the Cherokee has a shorter wingspan. The Cherokee's 30-foot wingspan gives it a much faster roll rate and faster cruise speeds at low to mid altitudes. A longer tapered wing creates more lift, giving it a greater rate of climb and greater wing efficiency as the aircraft climbs to higher altitudes. And looking to the rear of the Cherokee, you'll see another major design difference. That is, instead of using a fixed stabilizer with a hinged elevator, it uses a smaller, all-moving stabilator.
Well, the stabilator creates a smoother feel throughout the airspeed range. So when you are at absolute maximum speed, the yoke is not too sensitive. When you're down and very slow, it's not too sloppy.
The advanced design and manufacturing of the Cherokee helps to allow it to carry more useful load than other aircraft in its class. Let's compare the useful load of these 3 similar aircraft from different manufacturers. The latest DA-40 Diamond Star, loaded with 50 gallons of fuel, can carry 3 170-pound passengers and 50 pounds of luggage. The 172S Skyhawk from Cessna, when loaded with 50 gallons of fuel and 3 170-pound passengers, can carry slightly more baggage than the Diamond Star. But now if you take a look at the Piper Cherokee, if loaded with 50 gallons of fuel, it can carry 4 170-pound passengers and still have over 100 pounds available for baggage and supplies. Most importantly, you must always look at the actual manual that comes with the aircraft, and for the latest weight and balance report, because the weight and balance of this aircraft are constantly changing. You put in a new radio, you do a new weight and balance. During our flight testing, we noticed that the Cherokees tended to be quieter than the Cessna 172s. Using the identical sound equipment, let us switch back and forth between the Cherokee and the Cessna cockpit. We believe this may have something to do with the way Piper insulates their firewall, which is between the engine and the cabin. Another factor may be the angle of the windshield itself. And finally, the Skyhawk having 2 doors with pop-out windows may be contributing to the increased cabin noise level. However, virtually every Cherokee owner that we've talked to would gladly trade having a little more wind noise for having 2 doors to enter and exit. And finally, there's one more aerodynamic difference we'd like to cover between the high and the low-wing airplane. The high-wing aircraft will generally respond with more nose-up attitude when you add power, and the reverse nose-down reaction when cutting power. During flight, the stabilator or the stabilizer provides a downforce on the aircraft, loading up the wing. Now notice how the point of rotation on a high wing is higher relative to the thrust line than a low-wing aircraft. As you can see, the low-wing aircraft has more leverage to counter this downforce. This is why a low-wing aircraft tends to be more stable with power changes, and the high wing tends to require more frequent trimming throughout the flight. Okay, this pretty much sums up this quick review of the Piper Cherokee and how it compares to other high and low-wing aircraft. And right now, it is so exciting to see how our technology, Accu-sim, captures everything we discussed here regarding the differences between not just the high-wing and the low-wing aircraft in general, but the Cessna 172 Skyhawk and the Piper Cherokee. Thanks for watching.